All right, I am back. Let me adjust this. It's been 4 weeks, and the reason for that is because I went out of town for 2 weeks to see family and then to do Ragnar, which is a relay race where you camp out and run. Um, then I came back to work for 2 weeks, and unfortunately, the World Cup was on, which is mighty distracting, and Swift came out. So I decided Swift is obviously the future for Apple, so I might as well go ahead and start my project from scratch in Swift. The main reason for that is to convert. I knew I had to refactor anyway, so instead of spending a ton of time refactoring in Objective-C, might as well just learn Swift and fix the code while I'm doing it. And aside from a few beta bugs, just where the Xcode won't tell you the proper error, or just things that I got stuck on and you can't find on Stack Overflow, it seems like it's the right choice. The code base is much better now for the refactor, and it's easier to write in Swift. Just even things like writing a for loop in Objective-C, I have to look up the syntax of enumerate sometimes, and Swift, it just seems to write code much quicker. Anyway, so with that in mind, before even looking at technical stuff, let's see where the refactor's at. So this is the Swift project now. The good news is that a lot of the core systems are in place, so reading everything dynamic, the interface, waves of people coming in, the flags, the spawn, the environmental effects, the range that shows, all of that's back in. Combat here is back in. So the things that are missing are melee combat, catapults, the gate, and like damage over time modifiers. But aside from that, it's pretty much caught up, and it's all loading dynamically. So probably maybe one more week and I'll be exactly back to where I was. So that's good. So since I have nothing cool to show in the actual game this week, I figured I'd take a second to go over just code for people who are curious how games are made or how Swift looks compared to Objective-C. So from here on out, it's going to be pretty technical. So let's jump into that. So I picked out a couple points where'd I go? That I thought were interesting in the refactor. So first one, the flags. The flags where people spawn. I have let's look at those flags again. You click a flag, it's going to show you what type of unit can spawn there. And a different icon and a different cost. And it could be 2 icons, it could be 3. Back in the Xcode version, or the Objective-C version, take a look at this. So I did a base tower class, and then a subclass of a ranged, a melee, a catapult, and the actual castle, the 4 types of towers. And each of these was a protocol that had to implement certain functions, how to spawn soldiers, how to upgrade soldiers, what the range should be, and then what the upgrade path would be, what icons to show. And obviously the better way to handle this in Swift, or not in Swift, just in my refactor, is I just have a flag progression.plist. The archer flag starts at level 0 with this icon and this cost. Level 1 could show new icons and costs, so it's just an array of arrays that just one class flag will read into. So this now one file is responsible for spawning all flag types, and it just reads into JSON. And then if, let's say an example of something that gets more complex would be range. or range, or the environments that show when you spawn a flag. So for example, you click a flag, the range shows. So how wide should that be? How long should that be? Even more complex is which units does it affect and trigger or notify when an enemy walks into range. And then the environment, all this stuff that just spawned when you click the flag. If that were to become too much code for one file, I would just break it off into a service. So like an environment service or a flag service, and then helper functions. So an example of where I did that is range. So range is now an object. And it's created independently. No, it doesn't know anything about the flag. It just draws the circle, and so instead of this chunk of code being in the flag object, it's taken out. So that's kind of the spirit of the whole refactor. Move everything to JSON and get rid of all coupling. So another example of where I would have previously had things coupled is, so let's go with range. When someone walks into range, a physics object is or a physics event is triggered, and then the units are notified that, hey, a target's in range, and then they can make a decision to attack. And the way that used to work is I would have had the range object would have a member variable, self.units, and then when something walks into range, it would say self.units.notify something came into range. So it had this handle on a unit object. And now, when the range is constructed, I just I'm using closures as callbacks. So when a visitor enters the range, run this function, and when a visitor leaves the range, run this. So now the range doesn't need to know who it's notifying. It doesn't need to know anything about what it's notifying. It just needs to run this function anytime a unit walks into range or walks out of range. So yeah, so flags have been moved to JSON and decoupled from the things that they need to notify. Another example of where things came into JSON, which is going to look pretty straightforward, is characters. So the way my Objective-C code worked is I had a character node, and then I had a melee archetype and a ranged archetype, and then each type of character, archer was a file, ranger is a file, footman, skeleton. Each time I added a new enemy, I would add a new header file and implementation file. So this would have been 50 files deep, and each file, so like archer, had just all of this duplicate code. Make the physics body, even though it was probably a slight change over someone else's physics body. Reset the base frame, what their damage is, load their shared textures. So take a look at Ranger. It's going to be the same exact code, just duplicated. So every time I added a file, I had to duplicate the actual code. And then even worse, like in my physics for characters, I would have to write it visited specifically by a footman or specifically by a soldier. So each time I added a new character, I had to add it here too. And that happened in a couple spots. So now in the new way, character node is much lighter. Again, that's the whole, a character should just be a shell. It really doesn't need to know anything. So ways I made it lighter are, the biggest one is plist. So I still have archetypes because like a ranged defender, they're all going to have a shoot function. And they're all going to have the same behavior in the state machine. All ranged defenders behave the same. A melee attacker, similar. They all have the exact same physics body. So instead of making characters so generic that everything is data driven, I felt it's worth subclassing a little bit just because I feel like the attacks and the physics and all that's unique enough, instead of just doing in the character node, if ranged defender is set up this way, else set up this way, like a switch in here. I wanted to separate it out just for a little bit of flexibility. But what's gone is the actual footman, skeleton, archer, ranger, those are now just JSON files. So it'll grow, but a health, walking speed, who your parent class should be, or rather what type of object you are, what particle effect you use, how much damage, all that will be in the JSON now. So whenever I need to add a new file, I have to do two things, or a new character. I have to give them assets, archer attack, archer walk. So all that matters is it's the character name underscore attack underscore walk, and so the same name is here, footman walk. And then that's it. So if the assets exist and the plist exists, we have a character. So that was cool. And then another thing to make characters smaller, just as another example, is walking. So in the old way, I mean, it makes sense that a character class knows how to walk. So, I had move to point, move towards point, and move to next waypoint. And then move to next waypoint is actually quite a complex function, because you have to figure out, you have to draw an arc, and you have to pick to offset it to make it look like you're walking not on the same line as your friend might be walking. So every single character, good or bad, that gets instantiated has all of this code living within them, which is just a lot of code to carry in every object. So now we just have a waypoint service where you just pass it data. It knows nothing about the character it's moving, so it's not coupled to it anymore. And then here, just waypoint service, get action to waypoint, back in the character class. So it's making the character lighter, and then making the services generic and not knowing anything about what they're doing, just data in, data out, which is, it's making the whole project more flexible. Another example of, let's go to the state machine, just because that's a specific change to Swift. In the old way, so we're looking at the Objective-C here. This is, a lot of this I learned through an open source project, which I'll link to in the article. But basically, the idea of a state machine is, it'll help best to look at some more code. So enter moving, handle moving, enter engaging, handle engaging, enter attacking, handle attacking. Basically, you have states, attacking, moving, engaging. When a state is changed on a unit, it'll be enter will fire, and then handle will fire every single frame, and then exit will fire when you change states. So, for example, when I spawn a character, they go straight to waiting. And then based on if it's a ally ranged, the code will change them to rally if they're not at the rally point, so they'll walk to the rally point. Once they get to the rally point, they transition back to waiting. Enter waiting up here, just reset everything, and then if a target's in range, find the ideal target, and then engage that target, which will transfer to engaging. So like they just cycle through their states. And the way this was implemented in Objective-C was mainly around perform selector. This is a class, the state machine itself, and it will call, when you make a child class, you would implement enter wait PHX waiting or whatever function you want to override. And then if that function's implemented, so if it responds to this selector, call the selector for enter, exit, and handle. So that's why ally might have waiting, engaging, attacking, assisting, rallying. These are the ones it chose to make it respond to, but a ranged guy might only have these states he cares about. So anyway, so it's all subclassing, and then using perform selector to call the subclass function. In Swift, perform selector doesn't work quite that way. So instead, we basically just have a dictionary of states that you want to listen to. So we have dictionary of behavior, state, which is moving, attacking, rallying, etc. And then in that, a dictionary of enter, update, and exit, the three states of a state, or the three, you know what I mean. And then if that's there, call the function. So to give you an idea, range defender. I'll just make closures, enter waiting, update waiting. These are the functions. And then I'll add it to that dictionary. So I'll add to behavior state waiting, the enter function, the update function, and the exit function. So back in the state machine, when you change states, it'll just say, if the state exists in the dictionary, run it. So it's no longer, these behaviors are no longer a subclass. Or rather, they are, but they don't have to be here. I might actually refactor that. More importantly, they just, you're adding states to a dictionary, and then when the character is in that state, if it's callable, or if it exists in the dictionary, you'll run that function. So one is perform selector on a child class method, and then in Swift it's run a function if it exists in a dictionary. So that states how they changed. And then the last thing that I wanted to show you, kind of cool in the new Xcode. Who knows where it's going to go, but I hope it gets better. Let me expand this out 1 sec. You can bring me back to. So this is a scene editor. Or not. This is a scene editor that we can add objects to. And what makes this cool, so I have in my assets, Foothills is one of my maps. I just dragged the background image into the scene editor. So now I can move, like let's take a particle effect of waterfall. I drag that into the scene editor, and I want it to be right there. You can control all your sprites, and so in my ideal world, I could put the flags where they need to be and actually give them a class type of flag through the settings here. So right now, the only settings you can change are more generic: color, texture map, the physics definition, all the generic stuff. I would love to be able to actually give it a class type. That way, it would just work. Because right now, my process is I go to a drawing program like Pixelmator or iDraw. I put the map in there, and then I put the flags, and I write down the coordinates of where I put the flag. Then I manually write that into a JSON or the plist file, save it, and then as I need to tweak, it's just hard to read. Like let's look at the main plist file. It's just not fun to go through to edit. So if I could just come in here and drag, I want it to be a little over here or whatever, it just loads. And then the other nice part is, like back in the Xcode or the Objective-C way, you would have so you load the background image, I would load the waterfall, load the river, I'd write code to load all this stuff. Whereas in the using the scene editor, it just loads automatically. If I load test.sks, it'll put the background image and the water, the particle effects and all that. So I hope throughout the beta this gets more advanced, because this would save me a ton of time if this becomes more powerful. Anyway, okay, that is almost 20 minutes of looking at my code. Hopefully next week a little more exciting, but it was a tough grind, but I'm feeling good about where the code base is at now, and I'm all caught up in Swift. So, yep, next time, bye.